Hi friends, today I am going to discuss about the topic reflection of sound. How sound is reflected. Obstacles of large size which may be polished or rough is needed for the reflection of sound. This can be explained with the help of an activity. Take two cylindrical pipe. You can make this using chart paper. Arrange them on a table near the wall. Then place a clock near one of the end of the cylindrical pipe. Then try to hear the sound from other end of the cylindrical pipe. Now measure the angle of incident and reflection. Now raise the right side cylindrical pipe to a height. Then what will you observe? Now we can move on to next topic, that is echo. Just shout near a tall building or a mountain. You will hear the same sound after some time. This is called echo. The sound will persist in the brain for about 0.1 second. The echo may be heard more than once. Rolling of thunder is due to the successive reflection from number of reflecting surfaces such as land, cloud and all. Now we can move on to next topic, that is reverberation. Sound created in a big hall will persist due to the repeated reflection from the walls. Excessive reverberation is not needed in a hall. To avoid excessive reverberation, the wall and ceiling are covered with sound absorbent material such as fiber board. Now we can move on to next topic, that is uses of multiple reflection of sound. Using a stethoscope, doctor can hear the patient heartbeat. This is due to the multiple reflection of sound. And the ceilings of the cinema hall are generally curved so that sound after reflection reaches each and every corner of the hall. Range of hearing. Audible range of sound of human beings extends from 20 Hz to 20,000 Hz. And frequency below 20 Hz are infrasonic sound. Rhinoceros communicate using low frequency infrasonic sound. And frequency higher than 20 kHz are called ultrasonic sound. Animals like bat, whales communicate using ultrasonic sound. Now we can look into some of the application of ultrasound waves. Ultrasound waves are high frequency waves. They travel in a defined path even in the presence of obstacles. These ultrasound waves are used to detect defects in a metal block. These ultrasound waves get reflected back if there is a defect. Ultrasound scanner is used to obtain images of the internal organs. Ultrasound waves pass through the tissues of the body and it gets reflected back when there is a change in tissue density. And this ultrasonography are also used to examine the fetus during pregnancy. Now we can move on to next application, that is sonar. Sonar stands for sound navigation and ranging. This sonar consists of a transmitter and receiver. Transmitter transmits the ultrasound waves. This passes through the water. After striking the object, it gets reflected back. These are installed in a ship or boat. This is also used to locate the underwater objects and to determine the depth of the sea. Now we can move on to next topic, that is structure of human ear. Outer ear called pinna collects sound from surroundings. Then this is transmitted to auditory canal. At the end of the canal there is a membrane called eardrum. When compression reaches the eardrum, it exerts a force on the membrane and it moves inwards. And when a region of rarefaction reaches this eardrum move outwards. Thus the eardrum vibrates. These vibrations are amplified several times in the middle ear by the three bones, that is hammer, anvil and stirrup. This is then transmitted to inner ear. Inner ear converts these pressure variations to electrical signals. These electrical signals are then sent to brain via auditory nerve.